Hello. We'll see the effect of heat onto the liquid. So there are two types of effect we see. One is the temperature change and second is the phase change. In temperature change, we have already studied the specific heat. Now we will study one more constant there, that is the heat capacity. This heat capacity is similar to the specific heat. The thing is, when we have a system for which the mass is a variable thing, we keep changing the mass, which generally is the case in case of liquids. When we have a system for which the mass is not fixed, we tend to go by the specific heat. And when we have a system for which the mass is constant, we tend to go for heat capacity. So generally, we use the heat capacity for the solids and for machines also. And for liquids, we use the specific heat, like water and all. There we use the specific heat. Okay. So heat capacity. Heat capacity, it's the heat required. Heat capacity is equals to the heat required to change the temperature of a substance, and it can be any substance of any mass. So it's the heat required to change the temperature of any substance by 1 degree Celsius. So it's the heat required to change the temperature of a substance by 1 degree Celsius. Okay. So let's derive this again empirical method से हम इसको derive करेंगे. So if delta Q heat is changing, the temperature of a substance, any substance of any matter which is having constant mass by delta T. If delta Q heat is changing the temperature of any matter by delta T, then we can say delta Q by delta T heat will be changing the temperature of that matter by 1 degree Celsius, and that value is defined as C, that is heat capacity. It's a small c we use here. So C is delta Q upon delta T. That sort of a become formula. The value of C is a constant for a material. Generally for solid, this value of C is a constant. But again, similar to the specific heat, if we go for a large values of temperature, if we start going for large values of temperature, the C starts depending upon temperature. So small variation in temperature, generally C does not change. The variation is not that much. So we assume the C to be constant. And till 12th standard, we always assume C is a constant. Under classical physics or Newtonian physics, we assume the heat capacity for the material to remain constant. It does not depend upon temperature. Okay. If we see this formula further, if we modify this formula further, this delta Q will become C times of delta T. If we compare this formula, you see this is also a formula for delta Q in terms of delta T. If we compare this formula with the previous formula we have, compare it with, that was delta Q is equals to MS and delta T. If we compare this formula with this formula, the formula which we generally use for liquid, we will get C is equals to M into S. So you see, the heat capacity of any material is equals to mass of that material multiplied with specific heat. So when the mass is not constant, it's a variable, we tend to use the specific heat for substance, generally for liquids. Generally we keep changing the masses of liquid, and when the mass is constant, mass is fixed for some material, and that happens generally with solid, we tend to use the heat capacity there. Okay. Thank you.